Today, on how it's made. Cast iron tubs. Hopi Kachina dolls. Mine truck engine rebuild. And memory cards. An 1880s invention, the cast iron tub was first marketed in America as a horse trough and hog scalder, which could also serve as a bathtub. It was soon more popular in the bathroom than the barnyard. Its heat-retaining properties made a long and luxurious soak possible. The cast iron tub is one invention that's got a lot of people in hot water, and that's what people like about it. Today, they make cast iron tubs from scrap metal. Things like old heating radiators, water pipes, manhole covers, and even some car parts. Recycling scrap iron is more energy efficient and cheaper than mining it. A powerful magnet at the end of a crane arm lifts the heavy iron from the scrap heap and transfers it to big trays known as charging pans. The charging pans deliver the scrap to a center trough. This trough is a scale. It weighs the scrap and releases it to a conveyor. The scrap heads into the bathtub factory. Inside, it flows directly into an enormous electric induction furnace, heated to over 1400 degrees Celsius. The scrap iron melts into a pool of liquid metal. They run this furnace around the clock, and it's always 2/3 full, so that newly added scrap melts quickly. Huge hydraulic cylinders tip the furnace forward. The molten iron flows into a ladle. An overhead trolley carries the ladle brimming with the hot liquid metal to a holding furnace, which maintains its temperature until the next step. They're now ready to make a 2-part casting mold from sand, using steel tub patterns. To make one half of the mold, they fill a tub pattern with a mix of moist sand and clay. Hydraulic rams pack it down, and the mix takes the shape of the pattern. The clay is the bonding agent that causes the mix to hold the shape. Once the rams retract, the mold takes a trip under some blades that scrape off the excess sand. Machinery then lifts this half of the sand mold out of the steel pattern and transfers it to the other half of the mold prepared earlier. The two bathtub molds now come together, leaving a small gap between them. The molten iron, which has been transferred to an automatic pouring system, flows into portals in the top of the mold and into the gap at the center. The bathtub molds then move to a cooling line, and after chilling here for about 20 minutes, the iron inside solidifies. Then it's into a shaker device, which breaks apart the sand mold, revealing the newly cast iron bathtub. A robot retrieves the bathtub and stacks it. Next, an employee sprays specially formulated glass powder onto the tub. It's an undercoat for the enamel finish. They bake the tub until it's red hot. In the heat, the glass powder melts and adheres to the iron tub. A hydraulic device called a manipulator sets the tub on a pedestal. The pedestal swivels as they apply 2 more ground glass layers. These are the enamel top coats. On contact, the glass mixture melts onto the undercoat. The layers of glass form a permanent bond with the iron casting. Between coats, the tub cools, and they send it back into the furnace for a reheat. They place a mask in the base of the enameled tub. The mask is like a stencil. A robot blasts fine alumina oxide particles into the open areas of the mask. This etches an abrasive finish, leaving a subtle pattern on the surface of the bathtub. It creates visual interest and also provides a non-slip surface. The masks come in a variety of patterns for different looks. Whether it's a modern design or the traditional clawfoot one, these cast iron tubs should have no problem finding a home. The Hopi, a Native American tribe living primarily in northeastern Arizona, are known for carving kachinas, wooden ritualistic dolls representing deities, elements in nature, or the spirits of ancestors. They're traditionally presented in a dance ceremony to the girls of the community. Hopi Kachina dolls are cherished family keepsakes designed to teach Hopi children about the deities and spirits central to their Aboriginal traditions. Besides ceremonial purposes, many Hopi carvers produce Kachina dolls for sale to native art enthusiasts. The carver uses knives of different sizes, sharpening the steel blades after every 10 or 15 minutes to prevent dulling. Kachina dolls are traditionally made of cottonwood, not from the tree's branch, but from its root. The carver begins by shaving off the thin outer bark. With a straight cut from one side to the other, he shapes a bit of the single feather which will adorn the top of this doll's head. He makes a series of vertical cuts to form the face and hairline. He continues carving the head form, then, with a wood-burning tool, burns in the square outline of the face. He shaves away wood above and below to make the face protrude. He forms the face in more detail. Then picks up the wood-burning tool again, this time to delineate the neckline and the doll's robe. Back to carving. Now, with upward strokes, he shaves off wood to shape the neckline. He takes a larger knife and removes bigger pieces of wood to finish forming the head feather. Now he sands the wood with progressively finer sandpapers to remove all the cut marks left by his knives and to refine the doll's shape. With the doll perfectly formed now, it's time for the details and decorations. First, he sketches it all out in pencil. Then runs the wood-burning tool along the lines. He decorates the body, then moves on to the doll's hair and facial features. It's these details which bring the doll alive. What was a simple and ordinary cottonwood tree root has gone through carving, sanding, and burning to become an almost finished Kachina doll. He now coats the entire surface with clear varnish. This seals the wood to prevent it from absorbing the paint he applies next. About 40 minutes later, the varnish is dry and the painting can begin. Traditionally, Hopi carvers made paint from natural pigments, such as sand, plants, and berries. Today's carvers buy ready-made oils or acrylics. This carver dilutes acrylic paint with water to make it transparent. This allows the natural beauty of the wood grain to show through the color. After painting, he applies a coat of clear varnish to seal and protect the surface. Some carvers have moved in a new artistic direction: bronze. They use their wooden Kachina doll to produce a latex mold. Then, with this mold, cast a wax replica. They dip the replica in a substance that hardens into a heat-resistant shell. Then they put the shell in a furnace to melt away the wax. This leaves a cavity in the shape of the doll. They pour molten bronze into the cavity, and when the bronze cools and solidifies, they break the shell to extract a bronze version of their Kachina doll. Instead of paints, they apply chemicals which color the metal. A modern twist on an age-old Hopi art. A mine truck engine is a beast. The most powerful ones pack a brawny 24 cylinders, generating 4,200 horsepower. Compare that to 200 horsepower for a mid-sized car with 6 cylinders. But when they start to show the strain, it's time for a total rebuild. After about 20,000 hours of hauling heavy rock, it's time for renewal. Mine truck engines are routinely rebuilt, not just once, but numerous times. It's cheaper than buying a new engine, and it saves precious resources. Each rebuild is a massive undertaking. Virtually every component of this diesel engine will be remanufactured or replaced. As the team dismantles it, they inspect each part for wear and tear. They take it down to the immense crankshaft, the heart of this mine truck engine. With the crankshaft removed, they pull the lengthy camshaft out of the cylinder block. With the engine now in pieces, they clean every part that's salvageable, including the huge cylinder block. A couple of hours soaking in a hot sodium phosphate solution removes the grease and exposes the bare metal. Any imperfections are now more apparent. Using a depth gauge, a technician maps out flaws like this crack. It will need to be filled, and he makes a note of it. Next, a high-speed milling tool carves off a thin layer of the steel, taking the cylinder block's finish from grimy gray to bright and shiny. It also smooths away any unevenness to create a uniform surface for sealing gaskets around the cylinders later. After the intensive machining, the cylinder block looks like new. It's back to the crankshaft now. It too has undergone an extensive cleaning. Machinery grinds the outside diameter to a precise tolerance, equivalent to 1/20th of a human hair. This will allow new, thicker bearings to fit to it. The team clamps weights to the machined crankshaft. These weights mimic the load of engine parts like pistons and rods, as they now balance this critical part. The crankshaft rotates, and sensors detect vibrations and pinpoint the problem. After more grinding in these locations, they test it again to confirm the crankshaft is balanced. Back to the camshaft now. A member of the crew uses a black marker to highlight wear patterns. A grinder evens out the wear, and it also machines the profile of each lobe as it follows a metal camshaft master. The black marker lines vanish as the wear lines are smoothed, and the profile of the camshaft is improved. A major cleanup also transforms the rods that connect the piston to the crankshaft. A technician then places the rod in a special honing machine and activates it. 4 arms with gritty ends grind the inside of the rod head as the technician moves the rod back and forth. This sizes the inner diameter to enable the rod to fit to the other revamped parts. Once all the parts have been cleaned and machined, the engine is ready for reassembly. Using a crane, a technician lowers the crankshaft back into the cylinder block. He secures the crankshaft at one end with a metal bracket called a main cap. There are actually 9 main caps in total. He gives the crankshaft a spin to confirm that it rotates freely before installing the rest. With a piston now attached to one end of a connecting rod, he slides the other end into a slot in the cylinder block. This particular engine is a 16-cylinder one. It's considered mid-size for mining trucks. Once the gaskets have been fixed to the cylinder block, they bolt the cylinder heads to it. There are hundreds of parts in one of these monster engines, and it takes 700 person-hours for one rebuild. With this mine truck engine now fully assembled, they hook it up to a dynamometer to measure engine performance. They run it full tilt to confirm that it's firing on all cylinders and performing to the max. This rebuilt mine truck engine is ready to go back into service. Strong and heavily built, this 9-ton diesel engine should pull its own weight and then some. Music, photographs, documents. What used to take up shelf space in our homes and offices can now be stored on a tiny memory card or flash drive. You can save your files on it, take them out of the device and transport them anywhere, as well as delete data you no longer need. A memory card fits into a slot in your digital device. A flash drive plugs into a USB port. The key component of both formats? A memory chip, produced in a factory that's 1,000 times cleaner than a hospital operating room. It all begins with a wafer, a thin disk of pure silicon, a non-metallic natural element which conducts electricity. An automated container system moves the wafer through more than 800 operations. At each stop, the wafer receives one of several layers of non-conductive materials, such as silicon dioxide, and conductive materials, such as copper. The machines coat the layer with light-sensitive fluid, then apply UV light through a glass stencil of the complex pattern of electrical circuitry. The exposed areas of fluid chemically react, locking the material directly underneath into the circuitry pattern. Chemical baths then remove the surrounding fluid and material, leaving only the layer of circuitry, electrical pathways 2,000 times narrower than a human hair. A robot tests the circuitry for every memory chip on the wafer. A single wafer, measuring 30 centimeters in diameter, yields hundreds of memory chips. The goal is to make those chips as small as possible. In this industry, it's all about maximum memory in minimal space. That's why this operation thins the chips by grinding away 2/3 of the silicon from the backside of the wafer. And one last step before cutting the wafer into individual memory chips. This machine applies tape to hold the separated chips together. A computer-guided saw slices the chips apart. Cutting silicon is like cutting glass. It requires a diamond-edged blade. In the next step, a robotic arm, following the wafer map generated earlier, picks up the chips which passed testing and attaches each one to a fiberglass lead frame. The term lead refers to the frame's pins which connect the chip to the digital device. Another robot wires the chip to the lead frame with gold thread that's about the width of a human hair. Gold is very conductive, so now the pathway is complete. Electricity will travel from the chip circuitry through the gold thread to the pins to the device. After a machine seals the chip in plastic, workers gently snap them apart and insert them in memory card housings. This plastic and metal housing is for a memory card format known as compact flash. A small automated press locks the two halves of the housing together. The next station labels the front of the housing. Every single memory card undergoes testing for both function and speed. A laser machine etches product information into the back of the housing. These are another format called Secure Digital, or SD. They're assembled and labeled just like the compact flash cards. When the finished memory cards come off the assembly line, workers conduct a final visual inspection. On the flash drive assembly line, much the same process. A robot puts 20 lead frames on 20 circuit boards. Then a worker positions 20 USB connectors, which a soldering machine bonds to the boards. The final step, electronic testing, to make sure the USB connection is working and, via the circuit board, talking to the chip. The flash drives are now ready to go into individual housings. This model has a two-part plastic housing, which pivots in and out of a plastic case that can conveniently be attached to a keychain or lanyard for easy portability. Flash drive or memory card, storing your digital effects is just a click away.